Hello everyone and welcome to our first video on Unit 2.1, which is on quadratic functions. Now, as it's going to be very, very important to the rest of this section, um, especially this video, we're going to do a little bit of a reminder on how to complete the square like we were doing in section 1.2. So, given a quadratic expression such as this, the first step to do to complete the square is to factor out the a term from the first two terms if it's there. So in this case, there is a common factor of -3. So I'll pull out that -3 from the first two terms, leading us to just have an x squared. And then since we're factoring out a negative, it's going to change the sign, which means now it's going to be -8x. And then don't forget about your -19 that you have. Then step two would be to complete the square on the inside of the parentheses by adding and subtracting the b over 2 squared term. So just on the side here, I'm going to compute that. So b over 2 quantity squared would be -8 over 2 squared, which should be -4 squared, which is 16. So on the inside of these parentheses, I'll rewrite it. So -3 times x squared minus 8x. I'm going to add 16 and then immediately subtract it because that's just cleverly adding 0. And then don't forget about your -19. And the whole point of it is that these first three terms make a perfect square trinomial. They make x minus 4 quantities squared. They always make x plus the b over 2 term. So the b over 2 term was -4. That's why it's x minus 4 squared. Um, and then the last step then is to just distribute. So you've got -3 times bracket times x minus 4 in parentheses squared minus 16 minus 19. Well, I need to distribute that -3 in and simplify the rest of it. So that'll be -3 times x minus 4 squared plus 48 minus 19, which ends up being -3 times x minus 4 quantity squared plus 29. And that is the completed square version of our quadratic expression. The reason why we're talking about quadratic expressions is because now we get to talk about quadratic functions. So there are two main forms of a quadratic function. There is, of course, the most known one, which is standard form, which is y equals ax squared plus bx plus c, or f of x, because it's a function, technically speaking. And so that is standard form. It's the way we're used to seeing it. It's very, very useful for finding out what's it called? The x-intercepts, the places where it equals 0 by using the quadratic formula and everything, or by factoring by hand. But for other things, specifically graphing purposes, it's not as useful. Now we'll get into how it can still be very, very good in a little bit in the next video or two. But the other form is vertex form, which is y equals a times the quantity x minus h squared plus k, where h comma k is the vertex. I'm going to kind of underline vertex here. Key thing of note is that this a here is the same a. I have completed the square on this thing to get it in this format. So that a, both of these a's are synonymous. Now, how do you get from one form to another? So if you want to go the route of going from standard form to vertex form, you're going to complete the square. And you can see that just what we did above. We completed the square, and then we have it in that vertex form of an a times an x minus an h squared plus a k. And if you want to go from vertex form to standard form, which is somewhat rare to do, but it can still happen. If you want to go this direction, you're going to simplify. You're going to FOIL out this x minus h squared. You're going to distribute in the a and then combine any like terms that are left over, and you will get it back into standard form. So I underline this thing, vertex. What is the vertex? Well, the vertex is the point that is either a peak or a valley on the graph. So this point right here in this version of it. So this is going to be an x value of h. This is going to be a y value of k. This is the vertex. It's the point at either the very, very bottom or the very, very top of your quadratic function. Because quadratic functions will either open up like this or they'll open downward, which we'll talk about in just a second. Another thing that I want to draw onto this graph is a vertical line through the vertex. This line here, come on, let me grab it. Come on, there we go. This line is not actually part of the graph. It's something that we've drawn. This is called the axis of symmetry, which we are now going to abbreviate as AOS so that we don't have to deal with writing out axis of symmetry a bunch. It's really annoying to do. And so it is a vertical line. And if you remember from our unit on lines, a vertical line is represented by x equals a number. And since this goes through the point h comma k, the vertex, it must be that the equation for this vertical line is x equals h. So the h value gives you your axis of symmetry. And so to visualize what the axis of symmetry is, imagine I take a point right here, and then what I'm going to do is I'm going to draw a dotted line. And lucky me, I can draw perfectly straight lines, right? Over here, these 2 points are equidistant from the axis of symmetry. So equidistant from the AOS. That's how you could utilize the axis of symmetry to your advantage. If you know that this is like 5 units away from the to the right on the from the vertex, then this point over here will be 5 units the left, but it'll have the exact same y value. We'll utilize that in a little bit. So, how do I know whether my parabola opens upward or downward? Well, that has to do with the a value. So if the a value is greater than 0, then the parabola opens upward. And you can think about that in terms of linear transformations. If this is a positive number, then the curve is going to be just it's just going to be a parabola, which we normally see. It's just a linear transformation of x squared. But if this was so if this is positive, then nothing changes. So the parabola is what we call concave up, which will be a more important concept later on in calculus, but we still talk about it. And then the vertex is a relative minimum because you're going to be forming that graph. If a is less than 0, then the graph of the parabola opens downward. And the parabola is concave down. And so if you're looking at a picture of that, by the way, I should have drawn the picture for the other one. So might as well do that here. An upward facing parabola graph would look like this. And so your vertex is at the bottom of your graph, therefore making it a minimum. Whereas if you're opening downwards, something like that, then your vertex is a relative maximum. So one of the first things that we should do is try to make sure we get comfortable identifying all the pieces. So for the following quadratic functions, determine whether the graph opens upwards or downwards, find where the vertex and the axis of symmetry occur, and then find out if the function has a relative maximum or a relative minimum. So this one right here, we're trying to determine whether or not it opens upward or downward. And it is already in vertex form, but there's no a value. But yes, there is. There's a hidden 1. There's an implied 1. So a is equal to 1, which is greater than 0, which means that the graph opens upward, or just simply up if you'd like. Then we need to look at the vertex. Now this is in vertex form. A common mistake, so don't write this down, a student will say that the vertex is 5 comma negative 62, but that's not actually correct. The reason why is, remember, the formula for vertex form, to put something in vertex form is y equals a times x minus h squared plus k. So the problem here is that this is not in that format. So we have to rewrite this as x minus a negative 5. And therefore, then we can highlight this and this to give us our h comma k. Our vertex is negative 5 comma negative 62. Then the axis of symmetry comes from h in h comma k. That is to say, the axis of symmetry is the equation x equals negative 5. Remember, an axis of symmetry is an equation. It's a line, so it must be x equals. Writing negative 5 is not actually an equation. So unless it already kind of fills it in for you. Either way, if that happens to you, just let me know on the homework or whatever it may be, and I will work on getting you credit back. And so the last thing is, since we know that the graph opens upward, it's going to look like this. It's going to look like if you're feeling up, you got a smile on your face because you're positive, you're feeling up. And so the minimum, like the vertex will be at the bottom, making it a relative minimum. This next one here, it might look like it's not in vertex form, but it actually is. It actually is because of the nice properties of zero. You could rewrite this as negative 1/2 times x minus 0 quantity squared plus 1. There's nothing stopping you from adding or subtracting 0 from anything. That's totally fine. So back to the thing. A is equal to negative 1/2, which is less than 0. And since it's less than 0, it's negative. And if you're feeling negative, you're feeling down. So your graph is going to open downward, or simply just down if you want. Looking at it now in vertex form in all its glory, that means that its vertex is at 0 comma positive 1. And then its axis of symmetry will be x equals 0. Then the last thing, since it is opening downward, it's going to be a frown shape. If you're feeling down, you've got a frown, right? So it's a relative max at the top. The last one here is a little tricky. Well, I guess not really that tricky. It's just it requires us to do something first. It's not in vertex form. Sad face. So we can't find the vertex yet. There will be a way we'll talk about in one of the future videos, but right now the only way we know to do it is to we have to complete the square. Must complete the square. So I'm going to factor out the a term from the first two terms. So that's 2 times x squared minus 14x, and then plus the 98. We don't have to worry about that. And then half the b term squared would be half of 14, or negative 14 is negative 7. Square that, that's 49. So this should become 2 times x squared minus 14x plus 49, and then immediately subtracting 49 so that we're only adding 0, which doesn't change anything. And the whole point is that these first three terms make a perfect square trinomial. They make x minus 7 squared. Your b over 2. Negative 14 over 2 would be negative 7, and that's what that value is. And last but not least, now we've got to simplify. We've got to distribute. So you end up with that q of x. Well, I'll do one more step before calling it q of x. 2 times x minus 7 quantity squared minus 98 plus 98. Ooh, isn't that interesting? That goes away. So q of x is equal to 2 times x minus 7 squared, and that's it. So its a value is 2, which is positive, which means we're feeling positive, which means we're feeling up. So our graph opens upward. Now, at first glance, it might look like we don't have a vertex, but we've got to remember that technically speaking, we've got a plus 0 here. So we do have it in vertex form. So our vertex is 7 comma 0, And that means that our axis of symmetry is x equals 7 because our vertical line needs to go through our vertex, which means it has to have the same x coordinate. And then if we're facing upwards, if our graph opens upwards, we got a U shape like that, which means that our vertex is going to be a relative minimum, relative min. Let's just do that. And that'll do it for this video, and I'll see you on the next one.